guys. This is one of those lectures which is going to be more of philosophical than technical. If there is one session that I would want you to hold on to in these series of lectures, it will be this one, particularly if you are involved in material research wherein mathematical techniques play a role. Now, imagine that you have mastered the previous sessions. You have gained a complete understanding of different aspects that were discussed in our previous section, and you have complete command over them. Now, based on this understanding, you go to your friend and you say that now I'm able to model the charging of our phone batteries. Now, when you make this bold statement, generally your friend would expect something like this. Now, to a friend who is expecting something like this, when you deliver this to him, he will not be completely pleased, because for someone with expectation that is illustrated onto my right, what is presented is just colorful lines. He is not able to comprehend or relate what we promised to them and what we are giving him. Now, this is rather a gap, a huge gap in communication. Unfortunately, this huge gap in communication is not relevant only to the discussion that or the imaginary scene that we are considering, but it happens in real life. It happens when a researcher who primarily is involved in experimental studies discusses with someone who largely does theoretical works. They exist the same miscommunication. Now, what is the reason for this miscommunication? Now, if you are able to understand the reason for this miscommunication, our discussion with the experimental people will be much easier. It will reduce a lot of time in unnecessary topics. Now, let's go back to our imaginary case and understand what is the reason for this miscommunication. To my understanding, the reason for this miscommunication is two. One is we ourselves. In order to showcase the model that we have developed, in order to make sure that the model that we have developed after spending so much time is relevant and appealing to our other friends who are doing experimental study or who are working in a totally different area, in order to make them make our problem impressive, make our model impressive, in order to show that we are doing something relevant, we present it in such a way that it rather increases their expectation. They tend to think beyond what we can actually deliver. The other reason for this miscommunication is your friend themselves, because besides our statement, instead of rather focusing on the premise of our statement, what course are we talking about and what are the different contents that are involved in the said course, they began to imagine themselves based on the keywords they pick. Now, based on the keywords, they make an imagination, they build an expectation, and through that expectation, they look at what we deliver. So this also is a cause for a miscommunication. So the two sources of this miscommunication unfortunately often combine and create a huge gap. Now, how can we reduce this miscommunication? The possibility of reducing the miscommunication happens only when we understand the reason for this miscommunication, and we have seen that both the theoretical people who develop the model, in order to make it more appealing, they present it, or to make it more relevant, they present it in such a way that it increases the expectation. And the experimental people, unfortunately, without considering the premise from which this model is built, they make their expectation based on the keywords, so that when they see what we deliver based on their expectation, it rather seems often rather trivial. So in order to bridge this gap, in order to minimize at least this gap, we need to understand how we can approach a model. When someone says we have developed a model, we need to know how we can approach the model, how the model is rather built. Now, a fancy way of saying this at least could be the understanding the epistemology of the model. So what we mean by that is, let's consider the model that we developed in our previous session. So essentially, by model, what we mean by that is we have an equation that can tell us at a given time what will be the charge, the amount of charge that will be in our phone. If I put my phone on charging at a given time, after a given time t, what is going to be the charge in my phone? So what we essentially have is a predictive model. Now, this model is built for a specific ground truth. We have a ground truth, and for that this model is built, and that ground truth is to understand the charging rate and to understand what will be the amount of charge in my phone. And in order to understand that, we made several assumptions. So we have a ground truth that we want to address using theoretical models or theoretical understanding. We make assumption to make it several assumptions so that we are able to handle that problem. And the overlap of both these, the ground truth and the assumption that we made, the overlap of both these is the model that we have developed. Now, the overlap of these two grounds, the model that we have developed, gives us a specific insight. The specific insight on what could be the charge of my phone after a given time t. It doesn't address all the different aspects. The answer it addresses depends both on the assumption and also on the ground truth. So the insight that my model offers is specific to the ground truth I have considered and the assumption that I have made. It doesn't go beyond these two premises here. Now, if I'm clear about the ground truth, if I'm clear about the assumption, then it becomes possible for me to understand the insight that is offered by the model that we have developed. Now, this is rather a way to approach a given model so that the miscommunication can be reduced. Now, since this is an undergrad course, I'm allowed to take some more time to help you understand what we essentially mean by this, what we mean by approaching a given model. Now, let us consider this course here, and let us imagine that you have made a friend during this course. And after this class is over, you would like to take your friend from your classroom to her place. Now let's say that your classroom is point A and a place is point B. In our case, it's Orion and Opal. And unfortunately, you don't know the path from your place or the place from the classroom to that of her place. Now, there are several ways for you to answer this problem. The problem of not knowing how to reach place B or point B from point A. Now, one of the way of doing so is rather asking your another friend to give you some guidelines on how to reach from point A to point B. Even though you don't know the path, still you want to take a lead. So you ask your another friend to give him some pointers on how to reach point B from point A. So he gives you instructions like this: walk in this direction for say 100 meters, take a right turn, walk for 50 meters, take left turn. So you make note of all these directions. Now there is an alternate answer to the same question of moving from point A to B. That is, you can translate all these instructions graphically and you could have a map something like this. The solution A is rather having set of instruction. Solution B is rather translating the set of instructions into a map like this. So as your another friend is giving you instruction, instead of writing it down, you draft it as a map like this. Now, of course, you can enhance this map and then introduce all the different streets and alleys that you will pass as you are walking along the path that your friend has suggested. So initially there was text, and then you thought, okay, where you can create rather a graphical representation of the text. So you created it, and you thought maybe I would want a more advanced approach for this. I would want a greater understanding of this path, so I will include all the different streets and alleys. Now there is also an alternate way of solving this. That is, you can include more or less a map which has all the different landmarks as you walk along this path. So in addition to all the different streets and alleys, now you have different landmarks that will ensure that you are on the right path. So the amount of information gets added when you move from just streets and alleys to this map here. Now maybe you can also want to have an even sophisticated representation of your path wherein alternate routes are available. So in this sophisticated map, in addition to the preferred path, you also have alternate route along with all the landmarks that surrounds the alternate routes as well. So in addition to the landmarks that is in and around your original path, now you have representation of the alternate routes and all the landmarks that surround the alternate routes. And finally, there could also be a solution. Your another friend who is, a computer scientist could offer you another solution which is something close to a virtual reality, wherein the three-dimensional representation of all the landmarks and also the route you will be taking is given to you. So you have initially a problem from to move to point B from point A. you don't have a solution for it. Now you have different solutions for the same problem. One is you have written down notes on how to move from point A to point B. Now there is another solution wherein just you have a schematic map, a skeletal map of how to, just a translation or a graphical representation of the notes you have taken. There is another solution wherein in the skeletal map there are streets that are included. In addition to that, you have another solution wherein you have landmarks that are included. Another solution wherein there are, in addition to the landmarks, you have alternate routes that are present. And finally, you have a solution wherein you have three-dimensional representation of all the landmarks and including your path. Now, all these different solutions answer the same question. Now, if someone asks you which of these solutions would you choose, it depends not only based on the information it gives, but also another factor. Because as the information increases, the amount of memory it consumes, each of these plans it consumes correspondingly increases. So in that sense, each of these solutions, they represent a model, and each of these models, they consume different amount of memory space. The problem here is moving from point A to point B. There are solutions offered by different models, and now it is your decision or choose which of these models will be best suited for you. Now, if you want to move from point A to point B, choosing model 1 is, particularly if you are walking, choosing model 1 is not an ideal solution because it will not be a pleasant walk if you are counting your steps. And in the same way, choosing model F will also be a problem because it will not again be a pleasant walk if you ask your partner to wait before your screen uploads or reloads or whatever it is. So basically, model A and model F, they have, even though they offer a solution, they are limited or they are restrictive in one sense. On the other hand, we have 4 other models we can choose from. And based on what our requirement is, supposing if you are very good with direction, you can go with model B. Supposing if you want to know the alternate paths that are available, so that you can choose the longest path, you can go with model D. But ideally, someone without much of this information or much of knowledge about the direction would go for model D. The reason because there exists in each of these models, there exists a trade-off. The model that gives you least amount of information will also consume least memory. The model that gives you maximum information will also consume maximum memory. So when we are making a decision or when we are choosing a model, we need to understand what information it gives at the cost of what and what it ignores. Now this information comes after gaining a clear understanding on the problem that we would like to address. Now in this case, the problem is simple. But on the other hand, when we are facing a real life problem, only after gaining sufficient understanding of the problem that we are going to address, and after sufficient discussion with the experimentalists who are already working on the problem, we will be able to make an efficient choice of the model, because only then we will be able to confidently ignore certain aspects while choosing certain ones. Now, it is rather not so efficient if we spend $2,000 on a simulation to gain an understanding that could have been gained in a $1,000 experiment. If a $1,000 experiment gives a set of understanding to us, and if we do the simulation that could cost us, say, money equivalent or computational time equivalent to that of a $2,000, and the understanding that we gain is more or it's just equivalent to or less than what we are gained from experimental study, then it's absolutely no point in developing that model and running those simulations. So therefore, when we sit down and discuss with the experimental researchers, we need to understand the problem. The greater we understand the problem, the more we will be able to narrow down the key aspect and overlook the aspect that does not play a critical role. And in the same way, if you take that understanding and place it here, if our goal is to reach from Orient to Opal and to choose right path and without getting lost, then the efficient model here would be model D, because it provides all the necessary information, all the relevant information, all the key information with less consumption of memory. The same goes for approaching any model. So if someone talks about a given model and someone wants to build a given model, we need to know what key aspects of the problem that needs to be included and what are the other features that can rather be overlooked, that doesn't play a role in it. And of course, once we have model D, there is a possibility of rather enhancing it to model E and model F. So depending as this research progresses, it is often possible to develop model F from model D rather than starting from scratch. So whatever model that we develop serves two purposes. One, it addresses the problem at the given moment, and it also serves as a platform for further development that can answer questions in the future. So essentially, when we would like to bridge the gap between the theoretical researcher and one who does experiments, is that first to sit down together, understand the problem, and ensure that all the relevant aspects are captured in the model, and all the aspects that are not so relevant are rather, at least at this point, are rather ignored. At the same time, an experimentalist cannot expect a real life representation in the computational setup, a real life representation in the model, because it will no longer be a model. Now, to put all these things together in a simpler note, a model should not be too simple, and it should not at all be simple so that it's difficult for us to comprehend. It should not be too simple that it doesn't convey anything new. It should not be completely complex or not at all simple so that nobody is able to understand. It needs to be just simple. Now, if you are able to understand the previous, whatever we have discussed thus far, maybe you will be able to get this joke. That was rather, you could find this joke in one of the episodes of Big Bang Theory. So if you are able to comprehend, maybe this is a test you could test if you are able to understand what has been discussed thus far. So if you are able to comprehend that, you will be able to rather appreciate this joke here. Alright guys, so with this we will this is what we mean by the gun that was placed earlier. So basically, if there are some assumptions that, or there are some aspects of a real life situation, real life experiments that doesn't play a key role, it is rather our choice to ignore those and then build a model that only includes the key aspects. So with that, we will wind up this discussion and we will move on with the technical discussion or the technical stuff in the subsequent discussions. Bye.